Hey friends. Today's lesson 2 on angles and triangles. This one is a little bit trickier than what we did in lesson 1 in the sense that we're going to go through some proofs, and sometimes kids don't like the whole proving thing as much, but we're going to go through some examples. You're going to feel really good about it by the end of this, and then you'll have a chance to do some homework, okay? So the title of our lesson today is Reasoning with Parallel Lines. And as I said, it's the second lesson in this little chapter here. So we're just going to get right into it, and we're going to go through some examples together. Now, I'm going to hide my face for a very quick second so that you fully see this diagram, okay? Just in case you are at home without a workbook. Okay, so the conjecture is when a transversal intersects a pair of parallel lines, the alternate interior angles, which on that picture would have been angle 4 and angle 5, or angle 2 and angle 3, are equal. Okay, so I'm going to hide myself again as soon as I turn my ink on here. And we're just again going to say we're trying to show you that angle 4 and angle 5 are equal to each other, or angle 3 and angle 2 are equal to each other. Those are what alternate interior angles mean. So interior mean they're on the same side of the parallel lines, and then alternate means they're on opposite sides of the transversal. Okay, so let me just get myself back rolling there. And what we're going to do is essentially, when we're talking about alternate interior angles, look for a Z. Now, either that Z could be like a regular looking Z or a backwards looking Z. I'm going to hide myself one more time just so that you can see what I'm about to draw. And it would look something like this, okay? So that would be alternate interior angles. Okay, so how are we going to go about doing that? Well, these are the things we know right now, okay? In your workbook, you have a table for each of these questions, and you have statements and why you know those are equal. And I'll kind of walk you through this one so you can see how it's going to be done. So the first statement we would say is angle 1 equals angle 2, and the reason being is their corresponding angles. If you permit me to hide myself once again, okay, we can see here's angle 1, here's angle 2. They're in the same spot. We talked about that on the last lesson, right? They're in the same spot on each of the parallel lines. Essentially, they are the top right-hand corner of the intersection, okay? All right, next statement. We know that angle 1 equals angle 3, and the reason for that is that they're vertically opposite, okay? Again, I'll hide myself for a quick sec, and you can see right here, angle 1 and angle 3, vertically opposite, okay? All right, well, if angle 1 equals angle 2, and angle 1 equals angle 3, then angle 2 has to equal angle 3 because they both equal angle 1. Okay, and so we actually can conclude this one. This is just a 3-line one. We can say, so angle 2 equals angle 3, and the reason is the transitive property. Essentially, we have said because they both equal angle 1, they have to equal each other. Okay, that was your first proof. Wasn't that bad, right? We can do this. Okay. Let's try another one. When a transversal intersects a pair of parallel lines, the interior angles on the same side of the transversal. So take a look at angle 4 and angle 2. I'm just going to hide myself for a sec. If we were looking at angle 4 and angle 2, sorry, I just lost my ink here. Okay, angle 4 and angle 2. Okay, so a lot of times you'll hear teachers call this the C, because it kind of forms a C, but those are interior angles on the same side of the transversal. Now, I would want you to, first of all, look at those things and say, hey, those are not equal to each other. Okay, I would want you to be comfortable to say, I know those aren't equal to each other. Now, if you wanted to take a guess, by all means, please do. Our conjecture is actually going to be that they're supplementary. Okay. They're supplementary to each other, which means they'll add up to 180. Okay, so let's take a look and see what we come up with. So the first thing I started with is that angle 3 plus angle 4 equals 180. So let me just hide myself so I can show that to you. Okay, angle 3 and angle 4 form this straight line right here, right? They form that straight line right there. So they have to add up to 180. So we know for sure that angle 3 and angle 4 add up to 180. Okay, the next piece of the proof would be angle 2 and angle 5 also add up to 180. So now I'm down here and essentially saying the exact same thing. I'm saying, okay, these angle 2 and angle 5, they have to add up to 180 because they form that straight line right there. Okay. All right. So if angle 2 and angle 5 equal 180 and angle 3 and angle 4 equal 180, then I can say, well, that must mean that angle 4 has to equal angle 5. And the reason for that is alternate interior angles. That was the thing we just discussed on the last, I feel like I'm hiding from you. I'm going to put myself back here for a sec. That was the thing we just discussed on the last proof, right? So now we're going to use that in this proof. So angle 4 equals angle 5 because of alternate interior angles. You are allowed to use any property in a proof that's not the one you're trying to prove, okay? So obviously we couldn't have used angle 4 equals angle 5 in the last proof because that's what we were trying to prove. Do you see what I'm saying? But in this proof, we already know that that exists, so we can use it. So now look at everything we have. We have angle 3 and angle 4 add up to 180. We are trying to prove right now, I'm just going to get my ink back on and circle this for you. We're trying to prove that angle 2 and angle 4 would add up to 180. So look, angle 3 and angle 4 add up to 180. Angle 2 and angle 5 add up to 180. These are all things we know. But then we know that angle 4 equals angle 5. Well, if angle 4 equals angle 5, I can take this angle 5 and call it angle 4. Well, then don't I have a statement that reads angle 2 plus angle 4 equals 180? And that's exactly what we're trying to prove. Okay, so my next reason or statement would be, okay, angle 2 plus angle 4 equals 180. And the reason is substitution. We just substituted that angle 5 with angle 4 based on the last example or the last statement that we just made. Okay, so now we've proven that interior angles on the same side of the transversal, anytime you kind of see a C or a backwards C, those angles should add up to 180. Now, again, I just want to clarify, the title of this message was Reasoning with Parallel Lines, okay? And so these properties only work when the two lines that the transversal is cutting across are in fact parallel, okay? All right, let's take a look at this one. Prove alternate exterior angles. So we've talked about alternate interior angles. Those are ones on opposite sides of the transversal, but they're both within the parallel lines. These are opposite sides of the transversal, but they're both on the outside of the parallel line. So as an example, we have number 1 and number 6. So number 1 and number 6 right here would be alternate exterior angles. Okay, so let's go through what things that we know. We know that angle 1 and angle 3 equal each other because they're vertically opposite of each other. Okay, we also know that angle 2 and angle 6 equal each other because they're vertically opposite. Can you see where I'm going? All right, we also know that angle 2 and angle 3 are equal to each other because they're alternate interior angles. You can see that Z right here, right? Let me just draw that Z in for you, just in case you don't see it. So we're looking at something like this, right? That's the Z that tells me angle 2 and angle 3. I said those backwards, but angle 3 and angle 2 equal each other, okay? All right, now I think that's enough of me hiding. I'm going to bring myself back. Take a look at what we've written. If angle 1 equals angle 3 and angle 2 equals angle 6 and angle 2 equals angle 3, doesn't that mean that I can now say angle 1 equals angle 3? Oh, but that also has to equal angle 2 because angle 3 equals angle 2. And oh, that also equals angle 6, right? Do you see what I'm doing? So that proves to us, hey, that means angle 1 has to equal angle 6. Okay, so we used all of these to get to the whole angle 6 conversation. Okay, so let me just clear that ink and I'll put that statement in there for you. So now we know angle 1 equals angle 6, and our reason is substitution. Okay? Awesome. All right. Let's take a look at this now. And again, I'm gonna hide myself for just a sec so you can see the picture. The question is, determine the measures of A, B, C, and D based on things you know. Well, right away, I know that angle A has to equal 110. Okay, when I look at angle A, I see angle A is corresponding to that 110. Because these lines are parallel, that's what that symbol means too, by the way, if nobody ever told you that. Those symbols mean those two lines are running parallel. And then we also know that these two lines are running parallel. Okay, so because of the parallel lines, those corresponding angles have to equal each other. And so I know right away, angle A has to be 110. I also know right away now that angle B has to be 110 because B is vertically opposite to A. And we know that vertically opposite angles equal each other. Okay? It's fun. It's like a little puzzle. Okay, so now I need to take a look at angle C and see if I can figure out anything with angle C. So I see that angle C, look at this, on those parallel lines, that forms that little C, right? So that means A plus C has to add up to 180. They have to be supplementary to each other. Okay, so that tells me that angle C has to be 70 because it's supplementary with A, and we know that A is 110. So then we're looking at angle D, and we know that D is alternate interior angles with C, which means C and D have to equal each other. So that also tells me that angle D has to be 70 degrees, and my reason is alternate interior angles. Okay. All right, perfect. So that's what we're going to work on today. So in summary, key idea, when a transversal intersects two parallel lines, we have corresponding angles that are equal. We have alternate interior angles that are equal. We have alternate exterior angles that are equal. And the interior angles on the same side of the transversal are supplementary. They add up to 180. Okay. So corresponding angles, again, just to kind of refresh your memory, you're kind of thinking about the letter F there. That's kind of what you'll see. And you're looking at this and this spot, right? Alternate interior angles, you're kind of looking at the letter Z. Alternate exterior angles, there's not something that you can see there, but essentially it'd be like A with H, okay, on the outsides and on the opposite sides of the transversal. And then for the interior angles on the same side being supplementary, you're kind of looking for that C. Okay. All right. Good. Okay, next up, things we just need to remember. If a transversal intersects two lines such that the corresponding angles are equal, or the alternate interior angles are equal, or the alternate exterior angles are equal, or the interior angles on the same side of the transversal are supplementary, if you can prove any one of those four statements, then you've proven that the two lines have to be parallel to each other. Okay. Okay, when a transversal intersects a pair of parallel lines, the corresponding angles that are formed by each parallel line and the transversal are equal. When a transversal intersects a pair of lines creating equal corresponding angles, the pair of lines is parallel. So you can use one to get the other is all we're saying there. Okay, and then that's just like what we did in the last lesson. If you can prove corresponding angles equal each other, then you've proven parallel lines. If you have parallel lines, then you know corresponding angles are equal to each other. Okay? Okay, when a transversal intersects a pair of non-parallel lines, there's not all of those equality statements that we just talked about, so be careful of that. Okay? There are also other relationships among the measures of the 8 angles formed when a transversal intersects 2 parallel lines. Okay. All right, my friends, that was awesome. Now it's time for you to try some work. So I've posted some homework for you here if you are my kid at school. Take your time with these. Make sure you're trying to go through the proofs with reasoning, right? You always want to make sure you can back up your statement. Tell me why you know you can make the statement that you're making. Okay. And as always, if you have any questions, please, please, please make sure you ask them. That's what I'm here for. Take care, guys. See you soon.